This is John Stinger, and I'm going to be giving you an overview of the EPICS Capacity Planning module. So the Capacity Planning module is an add-on that extends EPICS functionality in a number of ways. It was introduced in the summer of 2019 as part of version 9.10. So if you're running version 9.10 or higher, this is a module that is available to you, and we're going to show you what it is and why you might be interested in trying it out. So first off, it allows better management of your plant backlog. So if you don't have the capacity planning module, you still have all the tools in EPICS that help you manage your backlog. You can set a routing for every part that indicates what work centers it needs to go through. And for each one of those work centers, you can set the number of days. And of course, you can look at the backlog and see what our overall load is for the extrusion department, the paint department, and so on, which uses those dates that are assigned to sales orders to show you completion dates. And so you can get an idea of what jobs are going to need to be run in each work center in the coming weeks. But the capacity planning module extends that significantly using a lot of rules that we're going to talk about. The capacity planning module also helps you more readily identify plant bottlenecks. So you may be able to look at your calendar and see, well, we've got a lot of jobs coming up in the extrude department, we've got a lot coming up in the paint department, and fabrication and anodizing and so on. But what you may not realize is that because of where or what time the bottleneck is occurring, that next week's overload in the fab department may very well affect a large number of orders that all need to go through that department. And again, because it's 2 weeks out, you may not realize that that's going to be a problem. So the capacity planning module makes that readily apparent and lets you take action to correct that problem. It also helps you provide realistic ship dates for your customer service who are entering sales orders. So right now you probably are, if you're looking at the backlog, are telling customer service, all right, for this week we are entering orders for delivery in the week of the 20th. And for painted orders, we're taking delivery for the 27th, etc. And that works pretty well, particularly if you have a semi-constant mix of orders that are coming through. And so by experience, you know approximately how long and each order is going to take and what your overall backlog is. But by using much more specific rules for your machines and for your calendar and for your individual parts, the capacity planning module is able to much more accurately determine for every individual order that comes in when the earliest date we could possibly be able to ship that item. And so you can then give your customer a much more realistic date rather than promising them a date and then finding out that we had a bottleneck somewhere and that order is going to be delayed. So as a result of that, it will improve your on-time delivery performance, because if you're giving a better, more accurate date in the front end, then when you ship according to that date, everybody looks like a hero. You met your ship date. It may be longer than the customer originally wanted it, because it always is, isn't it? But you were able to deliver on the date that you told them at the time that you entered the order. So it makes you look better overall and, again, streamlines the entire operation. So what is the front page that you're looking at here is the plant capacity chart. And this is by department and by machine and allows you to summarize in a variety of ways. But this is just a quick screenshot that shows you for our extrude department, we have pretty solid capacity booked for the next several days. And then there's some gaps and peaks and gaps and peaks and gaps and peaks. And that's kind of the way that capacity tends to flow. So if we entered an order right now, we would know, all right, well, if we schedule it for extrusion on the 22nd or after, we've got a pretty good chance of getting it out the door without having any delays, at least in the extrude department. Now, we may get downstream and hit a problem, and we'll talk about that in a little while. But the capacity chart is built in real time. So then at order entry, when they enter the order, you see I've got a 5-item order here on the screen, and EPICS has calculated for each of those orders when the best capacity-based ship date is for each one of those items. So you see that the first 2 items, EPICS thinks can be completed by the 22nd based on the routing and based on the load in each of the departments in the routing. The next item, the 21st, the next 2 items, the 25th and the 26th. And all of that is based on the properties of this particular sales order item, the part, the routing, the load in each one of the departments in the routing, etc. We'll dig into that in more detail. So it has told us for each one of those items, again in real time, what the best possible date is right now if we accept this order, when is the best available ship date? And it will hold that capacity then from order entry onward. So nobody else can grab that capacity away from you for their own order. And then because that last item on there was for the 26th, I can very quickly say, all right, well, if item 5 is not going to ship until the 26th, I don't want any of the items to ship before the 26th, which means now we can wait to extrude the first 3 items until the 21st. And the next 2 items we have to extrude on the 20th because they have a slightly different routing, or maybe it's a different press. And again, we'll drill into that in a minute. So the basics are pretty simple. Your capacity is the number of hours for each workday that each given machine is available. So the capacity on press 1 is 16 hours a day because we're running 2 shifts. The capacity on press 3 is 24 hours a day because we're running 3 shifts, except on Sundays when we're only running 1 shift, or Saturdays we're not open at all, etc. So the capacity is just simply the number of hours for each machine, each paint line, each packing line, each fabrication machine, etc. And the load then that loads that capacity is the number of hours that are required to produce each job. And of course, that's totaled up for all the jobs that are currently lined up waiting for that department. So then capacity planning is assigning those jobs to fill each machine's daily capacity. Now, every one of you is doing this now, a variety of ways. You may be using reports. You may just be looking at screens. You may have some very sophisticated spreadsheets that are using rules to determine what your capacity is and where you have bottlenecks, where maybe we need to open up additional capacity, where maybe we have excess capacity and we need to move personnel. So there are a lot of ways to get to it. And so we're going to show you how the capacity planning module deals with all those various rules. So again, basics are simple. We start filling the buckets, and we'll call it a bucket here just for the sake of this cool graphic that Scott put together. So we start filling the buckets as the jobs come in, and at order entry, the capacity is consumed as the orders are entered. So we get a new order in, it immediately looks for the best available plan to complete the job, and then seizes that capacity in real time, so that if 2 people are entering orders at the same time, they're not both giving out the same capacity. So it's being consumed as orders are entered. And of course, then when that bucket is full, then it'll move on and find another bucket. So if we can't extrude this on the 25th, well, let's look at the 26th and the 27th and the 28th, etc. And so we'll keep filling that capacity, keep filling that order until we have completed the order by loading capacity in each one of the jobs in the routing. So, but it gets complex very quickly. Every machine, of course, has its own production rate. So we know that the press can run approximately X number of pounds per hour, although it's different for every single die. We know the paint line can do approximately X number of square feet or square meters per hour. We know that the packing line on average can do X number of pounds or X number of pieces per hour, etc. And so when you start looking at a complex routing that goes through 5, 6, 8, 10 work centers, or things even that are going to an outside processor that has their own turnaround time, it gets very, very complicated to try to figure out for a given sales order when it's going to hit each of those departments and what the load looks like at that time when it hits those departments. And of course, each individual part may have its own production rate. So a simple part may be fabricated at X number of pieces per hour, but a more complicated part that needs CNC and so on, it takes 10 times as long, a tenth fewer numbers of pieces per hour, and so on. So it gets complicated in a hurry. And of course, some parts can only run on certain presses or certain fab machines. So we may be able to cut this part very, very quickly because it can use any saw, whereas this other one may need very complex CNC and has to wait its turn in line to get to the CNC machine. And finally, a large job may tie up the cutback department, right? I mean, you have a lot of pieces. It's going to take a long time to clear the cutback department. So you don't want that to affect delivery of non-cutback jobs. So just because we have a bottleneck there, we don't want to slow up our mill finish or paint orders just because cutback has a problem. So it's not one size fits all. And of course, some customers are more special than others. You have some customers that you have an agreement with that they get priority, probably because they're paying you extra. Or you may have rush jobs. Just the customer has a specific rush order that needs to come in. And so it needs to be not necessarily put to the beginning of the line, but given a higher priority and maybe get a higher percentage of the overall capacity than a standard order would get. So again, combine all those together and some other factors as well, and it gets very, very complex very quickly and very difficult to manage without a sophisticated tool to manage it. So first off, let's determine the capacity for a machine. For extrusion presses, because every die has its own rate per hour, and we keep history, of course, on that. And so we know that on press 1, this die has run at 1,500 pounds an hour, and on press 2, it's run at 2,300 pounds an hour. It's so on and so on for every single die that you have history. So all we need to know then to calculate our capacity really is just the overall hours per day for each and every day that press is available to run. And then we can determine which jobs, how long each job is going to take based on the die history. So the presses are pretty easy. Basically just tell us when you're open and how many hours. For other machines, well, you need to know not only the hours per day, but you also can set a standard rate per hour. So in this case, we have the paint line, which our standard is 5,400 square feet per hour. For our fabrication department, we've said, all right, our CNC machine 1 is 9.3 pieces per hour, and the rate for the second machine is 15 pieces per hour. And they're both open 2 shifts a day. For the packing department, we run them 3 shifts a day, 24 hours, and overall, 5,000 pounds an hour is about our average. And again, if you wanted to put that in as pieces per hour, you could do that. So it's really just, these are just overall numbers to give us a rough capacity for each of those departments. But then, of course, every die is different. So some dies can run on any press, some dies can run on a specific press, and some you might have more than one press, but one of them is preferred over the other, perhaps because it's easier to set up or for whatever reason. So in this case, this particular die can run on press 1 and 2, 7 and the 9-inch press. We have it set for press number 1 as preferred press. So when EPICS is planning capacity or calculating the work order, it's going to grab press 1 first if it can, and then move down to press 2 only if there's going to be substantial delay when it tries to plan for press 1. And for this particular die, the only press that's available is press 2. So capacity will not even try to slot it in to press 1. So if you have EPICS without capacity planning, you already have access to this. And this was actually a change in 9.10 where you can have multiple presses added per plant to the die screen. So if you already have that set up, you're already one step ahead of the game for setting up capacity planning. And of course, every part then is unique. So this particular part, we can run it through either of our cutback machines, our cutback saws in Blue Ridge. We get better rate on machine 1. We can get 750 pieces per hour on this. We can line them up across the saw and saw them all very quickly. Cutback saw 2 takes a little longer. Our deburr department, we can do 220 pieces an hour. And for our paint department, we can do 8,000 square feet per hour. And this is for this specific part. So this will override what the standards we saw were on the machine screen a minute ago. So the part level statistics always override the standards for the machines. And of course, as I said, some customers are more special than others. So by checking off the capacity priority checkbox on the customer screen, that indicates that every order this customer enters is effectively a rush order. You can override that for individual orders for other customers. So if you have a customer who's not set as a priority customer, you can still mark them as a rush order in special cases. So as we saw, we've set for the paint department that we are open by default for 16 hours a day, 2 shifts. So what does that mean? Well, as it relates to the calendar, that means that when we open the plant, and as you see on April 1st there, it says all with a green arrow meaning open. So that means on the 1st, every machine in the plant is open for their standard number of hours. So in this case, for the paint department, it will be open for 16 hours on the 1st. So unless you see something else there, if it's green, it's going to be open. But you notice down here on the 8th, we've said, all right, the paint department is open for 22 hours. So because we determined we were going to have a backlog, we have added another a third 6-hour shift for this week to try to fill in and complete some orders where we have a backlog. We even opened up Saturday for one 10-hour shift on the paint line. So the calendar overrides the hours per day that are set on the machine if we've specified something different on the calendar. As you see here, we're closing the paint line on the 15th for maintenance. So again, you can add as many exceptions to this calendar as you want. If your calendar always runs, and if you're open Monday through Friday, everybody runs the same number of shifts as normal, then you're good. But it does give you the ability, again, to open up a department for a weekend. We can open up packing for the weekend if we know that packing is getting backlogged and so on. Or we can close the department for maintenance or for whatever other reason. So how does that affect our capacity? Well, as I said, again, available or closed days can be set by plant, so everybody's open or everybody's closed. By department, so the paint line is open, the paint department is open, or by machine, so paint line 1 is running, but paint line 2 is down. And then the hours for each day can be specifically assigned or default to each machine standard, which is what we saw. So then after you've opened up a Saturday or Sunday, you can very quickly then rebuild the capacity plan. So we'll go out and look, all right, we had everything slotted in with Saturday and Sunday closed. We can very quickly rebuild the capacity plan to then shift things to fill in days after we add them. So that will have an immediate effect. It will basically compress your jobs as much as they can without changing the delivery date to try to open up space for either new jobs or for jobs that were running over capacity. And you can even add makeup days to the calendar. And what a makeup day is a date that the machine is open, but it's only going to be open to complete existing orders. So order entry, when they enter a new order, will not take advantage of that makeup day. It's only available, again, to make up work that we're behind on. So that's another option when you're adding dates to the calendar. So building that capacity chart, as I said, it is adjusted in real time. So the load is increased item by item as each new sales order is being entered. So if you have 3 people entering sales orders at the same time, they will each be assigned capacity as of that instant, the instant when they actually grab the ship date. And we'll show you where that is in a minute. And then, of course, as jobs are run, then that load is decreasing. The capacity is increasing. So as we run today, all those jobs are going to be removed from our load. Now, if we're running on schedule, then that really doesn't have any effect because you can't refill it. But if you're running behind schedule, you can see how that's going to cascade throughout the plant. And then adjustments to item ship dates also immediately update the plant load. So if you had an order that was going to ship this Friday, and you were going to start extruding it tomorrow, and the customer calls and says, hey, I don't need that for 2 weeks, by changing the ship date, EPICS will automatically free up that time. We'll again compress that job as much as possible to delay the extrude date until the latest possible time that we can start it to complete the job. Again, based on capacity of the other departments. Maybe it can't shift because we've already locked in a date that's available for paint or for packing. But in any case, it adjusts that load based on current situation at the time that you make those changes. And finally, priority customers and rush orders do get special attention so that we can say that overall, for a non-rush job and a non-priority customer, we only want to book our capacity at 75 or 80%. You can set that configured however you want it, so that we say, all right, for a 10-hour shift, we only want to book up to 8 hours to allow that extra 2 hours for priority jobs and rush jobs that are coming in. And then you can also set what the priority customers maximum is. So maybe you only want to take them to 95% and always leave a 5% slack because you may have unexpected downtime, unexpected other problems that pop up. And of course, as missed jobs occur, we were supposed to run this today, but we missed it for whatever reason. We had downtime, the die wasn't available, whatever. Then EPICS will automatically shift those to the next available dates for each department in the routing without adjusting the ship date. So it's possible that we may end up with an extrude date that is not going to be realistic, and it will flag you. You'll know, hey, we're not going to complete this job. You may want to notify the customer. But it does shift that capacity as jobs are missed. So how does that affect order entry, which is the starting point for all of this? So here's an order. It's a 3-item order. The first item is simple paint routing, order extrude paint. We've got a cut and deburr, so we not only have to cut it back, but we also have to deburr it. And then we have just a simple recut. So it's a mill finish recut job. So by hitting Control P when we get to either the ship date or the capacity ship date at order entry, EPICS will look at the capacity and calculate the earliest possible ship date running through all the departments in the routing that we can complete this job realistically. So these are all approximately 3,000 pound orders. The first item with the paint routing, EPICS thinks, hey, we can get that out by the 22nd. This cut and deburr is not, we don't think we can get it out the door until June 11th. And the reason for that is, and I can drill down and show you, but the reason for that is that our deburr department is overloaded right now. We've got a whole bunch of jobs coming through. They're only running one shift a day, whatever. But for whatever reason, our deburr department is overloaded, which pushes that job out to June 11th. And recut, it's just going, again, just a mill finish recut job. We think we can also get that one out on the 22nd. So best plan is to extrude these two on the 18th, this one on the 22nd, and carry on. Now you also notice the default press does play a role here. Item 3 is on press 2, which may have a different plan. So in this case, it didn't affect it, but it very well might. If we get in a lot of jobs for press 2 and not so many for press 1, and our die configuration says we can only run these jobs on press 2, then that can also play a role. So again, a lot of factors that really you can't keep in your head at once. You really need this sort of assistance to give an accurate date. So once EPICS has calculated that capacity ship date, then we've said, all right, well, if we can't ship item 2 until the 11th, then let's not ship any of the order. We don't want to have two truckloads going out to the same customer if we can avoid it. So let's select that we want to set the ship date for all of those items to June 11th. So we'll ship it all out at once. And so at that point, EPICS will then look at the routing again, look at that ship date, and recompress the plan for that job. So now we don't need to extrude the first item and the third item until the 5th of June because they're very simple. They're just requiring the paint department, and they've got plenty of capacity, and recut's got plenty of capacity, and we've pushed it out to the second item out to the 22nd, which is what it already had, because we've got again some sort of bottleneck going on in the deburr department. So maybe you need to think about adding another shift to deburr for a few days. Maybe you need to look at the specs for each individual job and see, hey, we can really do this faster than it says. We can deburr this at 500 pieces an hour, and it says we can only do it at 200. So there are a lot of ways you can make adjustments because this is giving you the information to say, hey, this job's going to take a while, and it lets you go out and see why is this going to take a while. So again, that's a very brief overview, and although it went longer than I thought, the capacity planning module is available for EPICS 9.10 and above. We can give you a 30-day license at any time. Just give us a call. We'll be happy to help you set that up, and you can run it either on your test database, or actually you could try it out with a user or two on your production database with real data. It's entirely up to you. The only thing that it's going to be affecting are ship dates, which will you could live side by side on the same database with it. So it's up to you how you want to manage it. Please give us a call, and we'll be happy to talk about it. And if you're watching this live, in just a second, we'll have question and answer. So thank you for your time.